We're so weirdly interrupted by a YouTube glitch. We were at CAB is congruent to angle CBA because if the sides are congruent, then the base angles are congruent. And AB is congruent to itself by the reflexive property. So we've got two triangles here congruent. So we can say that triangle DAB congruent to triangle EBA by side angle side. All right, so we're shooting for these little guys up here. Well, what's going to help us with that would be these guys, right? So angle ADF congruent to angle BEF by CPCTC. And then, so we already know one's congruent to 3, so by subtraction, angle EDF is congruent to angle DEF. Subtraction. And so DF is congruent to EF because if the bases are congruent, then the sides are congruent. So triangle DFE is isosceles since it has two congruent sides. All right, so that was number 18. Sorry about that, by the way. I never quite know what's going to happen on YouTube when I record. All right, next one up, last one of this particular problem set. So number 21 on page 363. Okay. Here we go. We've got a triangle. We don't know what kind, but we do know that this is a parallelogram. So this is A, B, C, D, E, F. We've got a parallelogram that's given to us. A, B, D, F is a parallelogram. And we are going to prove that triangle CBD is similar to triangle DFE. Okay, so this is, do you remember how to show triangles are similar? So let's see what we've got here. We've got a parallelogram, and we're looking at these two triangles here. All right, so we know that these angles are congruent, right? Opposite angles in a parallelogram are congruent. So angle A congruent to angle BDF. Opposite angles in a parallelogram congruent. Alrighty, then we've got parallel lines. So AB is parallel to DF by the definition of parallelogram. So this guy and this guy are parallel. Let's see, does that help us at all? And then we also know that BD is parallel to AF. We can include that in the same sentence. There we go. So let's see, these guys are congruent. These guys would be congruent. Okay, here we go. So here's a Z, right? So angle BDF is congruent to angle CBD because parallel lines, then alternate int congruent. So that's something way back when, but you're going to need to remember that. All right, we also have another Z over here, right? So angle BDF congruent to angle DFE by the same reason, parallel lines, then alternate interiors, congruent. So then we've got a transitive property here, right? So angle CBD is congruent to angle D, there should be an E, DFE by the transitive property. So we've got one pair of angles congruent. We need two, right? Let's see. What else can we get from this? Or we can do sides. So let's see, this piece here, we can do, well, isn't this kind of fun? Makes you think a little bit. Those guys are congruent. I don't know if that's going to help us, but I'll mark it. Those guys are going to be congruent. And we have, oh, I see it now. I wish I had a different color. There's an F. Do you see the F? You probably saw it before I did. You're sitting there going, Mrs. Curdy, don't be so lame. All right, so angle BCD is congruent to angle FDE because parallel lines, then corresponding angles congruent. Alrighty, so this guy here is congruent to this guy here, so therefore triangle ACBD is similar to triangle DFE by angle similarity. Go back through and make sure you've got all your similarity, ways of proving similarity down, and you know what they are. All right, so there's that set. We'll do another problem set soon.